All right, for 8.6, so when you have a fraction equal to a fraction, we are just cross multiplying and solving. So this one is a little bit easier. Remember that, like on number 1, if it were -4, you would pretend that it had over 1, and then you would cross multiply. When you have things being added or subtracted on either side, you need to multiply the equation by the common denominator, and always check for extraneous solutions. So something could have an extraneous solution when you divide by 0. So from the multiplying section, remember that the denominator cannot equal 0. So if we look at number 1, if I were to cross multiply, I would have 28 equals negative 20y minus 12. But what I'm going to have you do, actually, I'm going to have you leave it in factored form because it gets easier to do it that way. If you want to do the step that way, that's fine. But sometimes leaving it in factored form is easier when it gets time for variables and stuff. You can do it either way. It is okay. I just sometimes prefer this way because then it's easier to simplify when you leave it in factored form. So then you divide by -4, you have -7 equals 5y plus 3. Subtract the 3, -10 equals 5y. Y equals -2. Okay, so for number 4, I'm going to cross multiply. So I'm going to say 5h minus 2 times h plus 4 equals h plus 2, 5h minus 4. Then I'm going to FOIL it out. So we do have to FOIL. So I get 5h squared plus 20h minus 2h, that's a 2, minus 8 equals 5h squared minus 4h plus 10h and minus 8. The 5h's squareds will cancel. Then I combine, so 18h minus 8 equals 6h minus 8. Then 12h equals 0, so h equals 0. It's not extraneous because if I were to plug in h equals 0 into any of these denominators, they would not be, so 0 plus 2 is 2, 0 plus 4 is 4.
So then I got 12h equals 6h.
Then you subtract that over and set it equal to 0. So when h is 0, that will work out. Okay, let's look at number 5. Now we have denominators. So we can't cross multiply these because we have this plus 2 going on right here. And so I want to get rid of these denominators. How do I want to get rid of the denominators. And to get rid of them, I'm going to multiply the numerators by the least common denominator. So if I multiply those numerators by x, then those x's go away. Does that make sense? So I'm going to multiply the left by x, and I'm going to multiply the right by x. When I do that, whatever I multiply to the left, I can multiply to the right. I have to. And it will be okay. So then if I do that to this one, 5 over x times x just leaves me with 5 plus.
Oh, you just do the top, you don't do the bottom?
Right, just the top. It's like x over 1, x over 1. Plus 2x equals 6.
So you're trying to make it like just a constant.
I'm trying to get rid of the denominators. You do that by multiplying by least common denominator. And then I say 2x equals 1. So x equals 1/2. All right, so we said that the least common denominator for all of these is x plus 1. So I'm going to multiply the left side by x plus 1, and I'm going to multiply the right side by x plus 1. So look at this. It's not hard if you see what I do. So here, x plus 1 goes to each term. The x plus 1's cancel on the top, so I'm just left with 3. Then the x plus 1's cancel on this second one. The x plus 1's cancel, so I'm just left with 3x. The x plus 1's cancel, and I'm just left with 3 times x. Then on the left side, I have -1, the x's cancel, and I have -1 times x plus 1. So negative x plus 1.
Oh. Why is it a negative?
Because it's a negative right here. And so then I'm going to solve. So 3 plus 3x equals -x minus 1. I'm going to move the 1 over. So 4 equals -4x. Divide by -4, so x equals -1. Now I need to check and see if it is extraneous. So if I plug in -1 into my denominator, this right here, x plus 1, if I were to plug in a -1, it would equal 0. So -1 plus 1 equals 0. So then it would be extraneous solution. Okay, if we look at number 7, we have x minus 2, x minus 2, x squared plus 3x minus 10. So if I were to find a least common denominator with this, I would want to factor the x squared plus 3x minus 10. So if I were to factor this, what would that become?
X minus 2, x plus 5.
X minus 2, x plus 5. And so then my least common denominator would be what? X minus 2, x plus 5. So I'm going to take each side, I'm going to multiply that by x minus 2. Oops, I don't know where that went. I think I just erased it. X minus 2, x plus 5. I'm going to multiply the right by x minus 2, x plus 5. I'm multiplying the numerator, so it's like saying that over 1, saying that over 1. And so if I look at the left side, what ends up getting canceled out?
The x minus 2.
The x minus 2's end up getting canceled out. So I'm left with 2x plus 5 equals. Then I'm taking this x minus 2x plus 5, I'm distributing it to the first term. What ends up getting canceled out? The x minus 2. So I'm left with x times x plus 5 plus,
Don't factor it out.
not yet. And then the denominator is x minus 2x plus 5, so the whole thing gets canceled and I'm just left with 6. Now I'm going to FOIL it out. So 2x plus 10 equals x squared plus 5x plus 6. You have an x squared in there, so we're going to factor it. So I'm going to move everything to one side. I'm going to move everything to one side. So I have x squared plus 3x minus 4. Is it plus 4?
It's plus 4 minus 1.
It's minus 3x.
Minus 4 equals 0. Then I can factor this. How would I factor it? -1, positive 4. So x minus 1, x plus 4. So x equals 1 and x equals -4. Are any of these extraneous?
Is it okay if I do it the other way around? I got -3x plus 4.
That's okay. So none of these are extraneous, so they both work. And then that is all we'll do today.